ladies and gentlemen, this is something I'm super excited about. It's completely unnecessary, but let me tell you, I freaking excited. This is a claxton. It's an antique horn, often used in submarines nowadays, but it's a motor that spins around a piece of metal basically with a rivet and makes an Awoooga sound. We'll take it apart right here to show you how it works, and then we're going to install it into the simulator. I hate to break it to you, but this is not an April Fool's video. It's not gonna be a prank or anything. I'm actually gonna put this in my simulator because I can. Airplane. Sweet. Let's start by taking this apart. Here we have the HD UFW, the high density ultra fun workbench. Right here you'll actually realize there's a mount, so you can easily mount it to any like post or something. So that'll come in handy. Let's unscrew all these screws and see how it works. Ignoring the screws, there are three parts. The bell, and this is what amplifies the sound and really makes it directional. There's also the plate right here, and there's the motor. You'll realize right here on the plate there's a little divot. This divot actually interacts with this little geared tooth right here, and when the motor turns, it makes this go, I believe, up and down, because it'll jump on each step. Let's plug this in and show you how it works. Once I plug this in, you can see that the motor is turning. And then once you place this little plate on, since it hits this, it moves the diaphragm up and down. And so it's kind of like a speaker, but a little lamer. I think it's jittering like this because I connected AC power instead of DC power, which it goes off of. So really try to avoid AC power, and DC power is also better for the motor. We can then put the horn on, and it's a little louder. So now once we plug it in, it's slightly louder. Oh no, I killed it. So again, because I'm using AC power, it's the only 12-volt power supply I could find. This horn kind of alternates, but once you connect DC power, it should be a continuous flow of noise. I'm going to go over to the hardware store and pick up a 12-volt DC battery, and we'll get back to you. The wiring on this would be extremely simple. If this battery was 12 volts, we'd basically just put the positive to the negative, I think, the negative to the positive, but that's not enough voltage, so we have to put the negative to a positive, link them together, and then put the positive to, I believe, the negative, and then the positive to the negative. This isn't very good wiring at all. I'm just trying to show you kind of the concept, and I'm going to get thicker wire in a second. Ooh, wow. It sounds so much cooler with the right voltage. Wow. I gotta put a muffler on this. So now I can put a switch on it, and it'll only turn on when I turn the switch on. The neighbors are going to be super angry, so I'm going to put some tape over the end, just for fun. Now it should be quieter. That was quieter. And let's put another piece, just for good measure. Wow. This is angry. So now we have proof that this works. Let's make it a little prettier. and then install it. To be completely honest, this claxton is not part of the MVP, the minimum viable product. It is what we call feature creep, where you just like add another feature because you can. I'm trying to limit feature creep, but I want to have as many Easter eggs in my simulator as possible. I'm a fun type of person, hopefully. I want to have fun parts of my simulator. The first pillar of Captain Bob's mission statement is have fun. Then it's inform, and then it's inspire. Yesterday I spent probably 7 hours editing the heading indicator video, which wasn't really fun, so it's good to have a project like this. It's a lot better than just smashing the Q key over and over every time I make a mistake. Let's devise a mount for it, shall we? Okay, I have a few propositions. So my first one is to get this Awoooga horn and just put it on a brick thing and kind of let it go in the front of the simulator. So just put it kind of like this. But then I was thinking, why not add it to existing mounting hardware like this, and then add another angle like this to make the simulator even stronger. So it'd be both making it funnier and stronger. The issue with that is that there's not a lot of stuff to grab into. So we'd have to drill at a point right here, which I don't really know how to do, or drill all the way through here and then drill from the point. So this will be interesting. I'm not really sure how I'm going to do it, but I'm excited to learn. Another option would be to just drill it through the floor right here. So I managed to fit this in, and now we have our post. We now need to drill all the way through with the skinnier diameter, and then part of the way through with the wider diameter for the nut. So here's where we want to drill. Then we can attach this to the drill press and drill down this line. I'm thinking this would actually be better to do with a hand drill because the drill press I think will flip-flop, and we can put this at an angle right here. But I also do want it very precise, so I might actually just change the bench angle of the drill press and clamp it down. Oh, I'm weak, but what's wrong with that? I cannot get this. Boy, oh boy, oh boy, oh. I feel like I'm gonna break it. Or me. Oh! I think I did the first one, yeah. You learn something new every day. Let's set this at 45 degrees. We want this to not slide down. I was thinking that you'd have to clamp it like this, because that just kind of made the most sense to me. But this is kind of a wedge, and it would go up. So whenever you clamp it, it just slides up, more or less. Then it dawned on me that you can actually just do a stop block like normal, and clamp the stop block up and down. And then that just allows this to fall into the wedge right here. One more thing, since you're kind of drilling at an angle, make sure you won't drill into your bench right here. So if you need to, make a sacrificial bench. I don't think you're supposed to do that with wood, but I don't care. Ta-da! So now it makes a nice angled block, and we can drill the other hole. Righty-tighty, lefty, wait. You basically want to drill it until there's the ability to put a nut right and grab the threads. So you basically want to drill it until here. And that's what I've done. So the cavity goes in all the way here. And then there's a thinner cavity for the screw itself. So this is a counter bore. It's a larger hole that hides the nut. I can put this screw through the hole and then tighten the nut from here. I actually have to cut a second piece right here because I'm using the middle one as an Awoooga holder. That'll have there be 3, one on each side and one in the middle. Now we have these 3 blocks and we can put the middle one in and the 2 sides. Let's drill them in from the other side and kind of do it like we did these 2. This one is a little interesting because we need access to the nut right here, otherwise we won't be able to tighten it down. I'm going to make sure that this block is basically flush with the end of this panel right here. I can then drill 2 screws and go for it. Awesome. There are these 2 holes on the back, and that allows us to screw the Awoooga horn on, the claxton, and then screw these holes in, and it should all fit. There we go. That is sturdy. The best time to plant a tree was 20 years ago. The second best time is right now. I forgot to wire this before I put it in, but better late than never. I like this. So there we have it. Now we have an operational claxton in the Cessna 172 flight simulator. This really wasn't something necessary, but it was the best $20 I've spent in my life. Right next to the horn, I'll have a power strip going to a lot of the simulator outputs, and so I plan on putting a DC power supply right there next to it so it can run without using battery. That is all for this week's Cessna 172sday. Wow. I'm getting emotional. Yeah, no I'm not. Goodbye.